Hi folks and welcome. Today we'll cover the basics of Solar Jetman physics and flying from the very beginning. To begin, we'll open Unity and create a 2D project before we go ahead and create an empty object. We will rename this object, this is the spaceship, and it will be the player in this game. And we want to add some components to this, such as the rigid body and collider. We'll also add a sprite renderer to capture some spaceship. So next we want to import the sprites in order to capture the spaceship and some of the boost animations that we'll do shortly. To do this, you drag in the sprite sheet. Now this was a sprite sheet that contained the original Solar Jetman assets, but I also added and colored in a few extra myself. This is something I can share for those who would like to use it. However, the sprite sheet needs to be sliced. It does contain multiple assets, so you have to click the multiple within the sprite mode and then go to slice, and it will cut up all the individual assets within that sprite sheet. One more thing that you need to do is to change the filter. You can see that they are a bit blurry and you need to change it to point, and that will remove the blurriness. At this point you can choose an assets or sprite for the spaceship. Here I'll go with the black spaceship, and we just click and drag that into the sprite renderer. We may also need to resize it, so I think 10 should be fine. And now we can see that we have the spaceship and it's in the game. In order to fly around in the same way as Solar Jetman, we need to add a few reference points, and these can be done by creating child objects of the spaceship. In order to do this, you right click and do create empty, and we will rename the first one to the player reference point, and we'll also change the color here so it shows up in the editor. And if we zoom in, we can see the blue dot here. We'll add another one, and this will capture the direction that the player will want to travel in. So we'll call that the reference direction point, and we'll also change the color there. But crucially here we need to give it an offset, and any offset we give this here, because it's a child of the spaceship, it will be retained even if there is some rotation or transformation of the spaceship object. And this will give us a vector between the center of the spaceship and the reference direction, along which the player will be able to add force or boost, which we will get to shortly. The next one is the boost spawn point, and this is where we want the boosting animation or boosting asset to spawn in. Again, we need to give this a bit of an offset below the spaceship. And there we have it. We have these 3 points for reference, and we'll use them in the script. Next we want to add a script or a controller script to the spaceship so that the player can move and fly around. To do that, you hit add component on the spaceship and click new script, and we will give this script the name vector thrust. Once the script is created, we want to double click on it to open it. So we'll open Visual Studio so that we can begin to edit the code here. And once that's open, we want to scale it and zoom in a small bit for clarity before we begin to actually script the controller. To begin, we want to add a reference to the rigid body. And we also want to make available the transforms of the 3 reference points that we defined earlier in the script: the player reference point, the player center point, as well as the boost spawn point. And we do that by making these objects public. We will also add a float value here to capture the strength of the boost that we will apply. At this point, we will define the rigid body of the player in the start function of the script. Next, in the update function, we will add a few vectors that will capture the change in the player's pointing direction or pointing vector. This will allow us to capture any changes in the reference points that are a result of the spaceship moving, as these vectors will be updated once per frame within the game logic. What we want to call here are the positions of the spaceship reference point and the spaceship center point. And we do that by calling the game object, the transform, and then the position after it. To establish the direction of the spaceship, we'll define a new vector called the pointing vector. And this will be the difference between the spaceship center and the spaceship reference. And through vector addition or subtraction, that will give us the pointing direction of the spaceship. We will add some player controls here, the first being the boost activation, and we do this using the input.get key. The if statement here is essentially to capture when the button is pressed, do something. And in order to achieve the kind of thrust physics, we will use the Unity out of the box add force, and we will apply it along the pointing direction of the spaceship times the boost strength that we defined earlier. And what we can do is we can play with the boost strength to really give a different feel for the strength of the thrust. We can add an else statement here to capture when the boost is off. Now this will be useful for the animation or the thrust being activated, so we'll leave it empty for now. Here I try and pass in a Python pass statement, which won't work in Visual Studio. We'll move on to some player input for left and right, or some direction change for the spaceship. And it's defined quite similarly with an if statement and input.getKey for left and right. How will we achieve the change in direction? Well, we'll do it through the rigid body transform rotation. And we don't want to rotate in the X and Y, we want to rotate in the Z. So when the player presses the right key, there will be a small rotation, -5 in the Z. And if the player presses the left key, there will be a rotation in the opposite direction. If you increase the numbers here, the rotation will obviously take place faster, and that's going to be essentially down to the game feel. Finally, we will change the update function to fixed update, and this will be useful for limiting the frame rate. We will save this script now, and we will go back to the Unity editor. We'll give it a chance to update the script. You can see that the vector thrust script now has 3 components that we need to add. And what we do is we drag down the reference direction object into those publicly defined game objects in the script. We also add a value for the boost strength. Before giving it a try. We press the boost button. We'll try right and left. So we can see that we do have the movement, and we can move in the directions similar to Solar Jetman. The level gravity is offered by the rigid body use gravity checkmark. We can uncheck it to see what it would be like to fly around in free space. Join me next time where we'll add a boost and a boost animation, as well as how to control the animator. See you next time.